Internal rotary gear pumps have proved themselves to be dependable and efficient in many types of industrial pumping applications. They handle liquids ranging from light, volatile, liquefied gases to heavy, viscous liquid and semi-solids. The simple pumping principle has only two moving parts, a gear within a gear. This cutaway view shows the flow of liquid through the pump. Power is supplied to the shaft attached to the larger gear or rotor. As the gears unmesh, liquid is drawn into the pump, filling the space between the gear teeth. The liquid moves smoothly past the crescent and is forced out the discharge port by the meshing of the gear teeth, as indicated by directional arrows. Rotary gear pumps operate equally well in either direction. Before installation of the pump, obtain and read the technical service manual furnished by the manufacturer. Be sure to read all warnings and caution information. When the unit is placed on the foundation, it should be leveled by using shims located at the anchor bolts. On a long base, additional shims may be needed on the long sides of the base plate. After the base plate has been leveled, tighten down all anchor bolts. The pump should have a good foundation. To obtain the maximum service life, the base plate should be completely grouted with a non-shrink type grout. Always locate the pump as close as possible to the supply of liquid to be pumped. Locate it below the liquid supply if at all practical. The pump should be located where it is accessible for inspection, maintenance, and repair. For large pumps, allow room to remove the rotor and shaft without removing the pump from the base. The cause of many pumping problems can be traced to the suction piping. It should always be as short as possible and should never be smaller than the pump port connections. Be sure the inside of the pipe is clean before hooking it up. When approaching an obstacle in the suction or discharge line, go around the obstacle instead of over it. Going over it creates an air pocket. Where practical, slope the piping so that no air or liquid pockets will be formed. Air pockets in the suction line will make it hard for the pump to prime. For a suction line with a long horizontal run, keep the horizontal portion below the liquid level if possible. This keeps the pipe full so the pump does not have to remove so much air when starting. When piping a hot or cold system, be sure allowances are made for expansion or contraction. Loops or expansion joints or unrestrained runs should be used so the pump casing is not distorted or put into a bind. It is always good practice to consider a strainer on the suction side of a rotary gear pump. Without a strainer, foreign objects could be drawn into the pump, causing a jammed pump, a broken part, or a torn-up drive. Provision should be made for cleaning the strainer. If the pump is to operate continuously, a bypass should be built around the strainer, or two strainers should be put in parallel with proper valving so they can be isolated for cleaning. A swing-type check valve is recommended in the suction line close to the pump. The pump should not be used to support the piping. The weight of the pipe should be carried by hangers or other supports. When fastening the piping to the pump casing, springing or drawing the piping to the pump will cause distortion, possible misalignment, and probably rapid wear of the pump. Do not use the pump to correct errors in the piping layout or assembly. All joints of the piping system should be tight. Pipe dope or Teflon tape will help assure leak-free threaded joints. Leaks in the suction line permitting air to be drawn into the system may cause a noisy pump or a reduction in capacity. Check the alignment of the drive couplings after the piping is hooked up. As a final check on pump alignment, remove the head of the pump and with a thickness gauge, determine if there is clearance all the way around between the rotor and casing. A rotary gear pump is a positive displacement pump. This means that when the pump is rotated, liquid will be delivered to the discharge side of the pump. If there's no place for this liquid to go, the pressure will build up until the motor stalls, the drive equipment fails, a pump part breaks, or the piping ruptures. To prevent any one or more of these things from happening, a safety relief valve will relieve the pressure at a predetermined value, thus protecting the entire system. The internal type of safety relief valve should always be mounted with the cap or bonnet pointed toward the suction side of the pump. The return to tank type of safety relief valve should always be mounted on the discharge side of the pump. If the pump rotation is to be permanently reversed, the internal relief type of safety relief valve must be turned end to end. The return to tank valve must be moved to the new discharge port. A pressure relief valve should be installed in any part of the pump or piping system that can be valved off and thus completely isolated. This is particularly important when handling a cold liquid, such as refrigeration ammonia, or a heated liquid, such as asphalt or molasses. Before pushing the start button, check the following. Are there vacuum and pressure gauges on or near the pump? These gauges are the quickest and most accurate way of finding out what is happening in the pump. Check piping to be sure there is no strain on the pump casing. Rotate the pump shaft to be sure it turns freely. Jog the motor to be sure it is turning in the right direction. Check any safety relief valve to be sure it is installed correctly. Check the suction piping to be sure it is all connected and tight, the valves are open, and the end of the pipe is below the liquid level. Check the discharge piping to be sure it is connected and tight, the valves are open, and there's a place for the liquid to go. Lubricate any grease fitting on the pump using a good general-purpose number 2 ball bearing grease. Check any gear reducer or motor coupling and lubricate as recommended. For packed pumps, loosen the packing gland nuts so the gland can be moved slightly by hand. Adjust the gland to reduce leakage only after the pump has run long enough to reach constant temperature. The packing should weep a little to keep it cool and lubricated. Make sure all guards are in place. When the pump is started, it should begin to deliver liquid within 60 seconds. If it does not, push the stop button. Running the pump for longer than 1 minute without fluid will ruin it. Review the steps just outlined. If everything appears in order, put some liquid in the pump to help it prime. Start the pump again. If no liquid is flowing within 2 minutes, stop the pump. It may be necessary to vent the discharge side of the pump until liquid begins to flow. After the liquid begins to flow, a few preventive maintenance procedures will extend the life of the pump and reduce the cost per gallon pumped. Grease the unit every 500 hours or after 60 days, whichever occurs first. If service is severe, grease more often. Do it gently with a hand gun. Use a number 2 ball bearing grease for normal applications. For hot or cold applications, use the appropriate grease. Occasional packing adjustment may be required to keep leakage to a slight weep. If impossible to reduce leakage by gentle tightening, replace the packing or use a different type. After long service, the running clearance between the end of the rotor teeth and the pump head may have increased through wear to the point where the pump is losing capacity or pressure. Resetting the end clearance will normally improve pump performance. Periodically remove the head, examine the idler, bushing, head, and pin for wear. Replacing a relatively inexpensive idler bushing and pin after only moderate wear will eliminate the need to replace more expensive parts at a later date. If trouble does develop, one of the first steps toward finding the difficulty is to check the vacuum gauge in the suction side and the pressure gauge in the discharge side of the pump. Readings on these gauges will often give a clue as to where to start looking for the trouble. A high reading on the vacuum gauge might indicate the suction line is blocked, foot valve stuck, gate valve closed, or the strainer plugged. If the liquid is too viscous to flow through the piping, the lift too high, or the suction line too small, the vacuum gauge reading would also be high. A low reading on the vacuum gauge might be caused by an air leak in the suction line. The end of the suction pipe may not be in the liquid, or the pump may be worn or may need to be primed. A high reading on the pressure gauge might indicate high viscosity, a gate valve partially closed, a plugged filter, liquid in the line not up to temperature, or the relief valve set too high. A low reading of the pressure gauge could be caused by the pressure relief valve set too low, the relief valve poppet not seating properly, the bypass around the pump partially open, too much end clearance between the rotor and pump head, or a worn pump. If either the vacuum or pressure gauge shows a fluttering, jumping, or erratic reading, it may be caused by liquid coming to the pump in slugs, an air leak in the suction line, or vibration from misalignment, or mechanical problems. When properly installed, piping supported independently of the pump, all couplings aligned, safety relief valves set correctly, piping of the correct size, and good preventive maintenance, a rotary gear pump will operate for months or years before gradually losing its ability to deliver capacity or pressure.